today questions. Today is 3rd March, and the question is having the maximum value of an ordered triplet. Second, the first we have already done yesterday, and as you can see here, right, we have given that the zero index array we have given. We have to return the maximum value over all triplets of indices. Maximum value of all triplet of indices I, j, k, such that j should be greater than I and less than k. If all such triplets have a negative value, return 0. Otherwise, the value of the triplet indices I, j, k is equal to nums at I minus nums at j, and the result will get multiplied by nums at k. Okay. For example, you can see we have given input this, and for that it is saying the explanation, the value of the triplet is 0 to 4, because if you do the calculations right now, if you put the value of I, j and k, you will get 77 as a value. So it can be shown that there are no ordered triplets of the indices having value greater than 77. Okay, and for that what we have to do, we have to make a for loops, right? So for that we'll create n variables. We can get from nums dot length, right? We can get with the value nums dot length, and then we'll create a for loop. Before the for loop, let's suppose we have to create a result also, right? So int result, as you know, yesterday we have already created this, right? So result, and we'll mark it at 0. Then we'll create a for loop, and the for loop will start from I equal to 0, and it should be less than and then I plus plus. Similarly, we'll create a for loop int j, and we'll start from the 0, not 0. Okay, all the possible value we have to get it right, so it will be I plus 1, as you know, right? Yesterday we have already done this. I plus 1 will take, and the j value should be less than n and j plus plus. Okay, now go for creating the value k. Int k should be j plus 1, right? And k should be less than n and k plus plus. So we will have all the combination of values, and we can follow the indices value that where j is greater than I and k is greater than j. Okay, here key will be biggest value over there, right? And then you can find the data, right? So what we have to find, we have to find this value, as you can see, right? Or you can get from here also. Okay, so this is nothing but your result. So as you know, result have already some value, because till that we have 0, right? So what we can do, we'll do math dot max, and then we'll pass result here, and then this value. Okay, and then after, once these are done, we'll return result. So one mistake we have already done, that is, as you have gone through my yesterday video, so I have taken long, and if you will take the long, there will no problem, right? But we have to also convert these things into long, right? I hope this will work, right? And so let me run, submit this. So as you can see, the code is working fine, but it is coming time limit exceed, right? error. So how we are going to solve it, that we'll see further. Okay, so what you can do, you can pause this video, right? You can pause it here, and then you can try to improve this. The better thing is that if you have if you take a prefix value here, right, between these two or this one, right, and then if you keep adding the value, right, subtract the value, then you can find the result, right? Okay, better you pause the video and try to solve it. Okay, so guys, as you can see here, that we have already seen the optimization, code optimization, right? But in this video we will see how to optimize this, and what is the approach that we have to follow, right? So if you remember the previous submissions, right, where we have seen that we have taken 3 for loops, and that is why the time complexity exceeded of NQ, which is too slow for the large input, and we can optimize it by O of n by using the prefix and suffix arrays, right? So what we can do here, we'll create some prefix values. Like, let's suppose if you want to track the maximum of each index using a prefix maximum, right? So we'll call it a prefix max, right? So we will optimize, like we will take a we will track a maximum, let's suppose nums at I minus nums of j, right? If we have nums at I and nums at j, that is called prefix maximum. Okay, so we'll take a maximum of nums at I and nums at j, that is called prefix max, right? As you can see here, I can take it like this. This is the value, this is the suffix max, right? You can get it. Okay, and then we'll track nums at k. As you can see here, nums at k will take for each k using a suffix max, right? So we'll take a prefix match and we'll take a suffix match. Once these two we have, like we will track the both maximum of those two, prefix max and suffix match. Then we'll iterate over j, right? We'll try to iterate over j, and then what we will do, we'll compute the best of nums at I minus nums at j and the calculation, and then we'll multiply nums at k for each O of n times. So the time complexity will get optimized from O n q to O of n, right? So this is our approach that we are going to see here. So as you can see, nums we have already given, right? We'll find the n, and then what we will do, let me zoom little bit. Yes, as you can see here. Okay, so as you can see here, right, what we can do, we will do we'll check if n is less than 3, we return 0, because that is not enough for the triplet, right? For the triplet, at least 3 elements should be in the array element, right? If array element is not less than if let us less than 3, means we have to return 0. Otherwise what we will do, we'll find a prefix max to store the max num, so that we will keep track of the value, right? So we'll create a prefix match here, right? The prefix max will be having the same number of element in the array we have given, and so we'll take n. And then the first element we'll store on the prefix match is from the array element, first element, and then we'll start from I equal to 1 to n, we'll go and we'll find the max, right? So we will keep track of all the max value will in the prefix max at I. Once you have, means you all the prefix match is already stored now on this prefix match array, right? Now we'll come to suffix max to store the max of num k, and so what we will do, we'll create a suffix max equal to new int n, and then the size will remain same, and then we'll store n minus 1, because this is suffix, right? Once you have a prefix and suffix, right, created, then you will assign the last value, last elements value n minus 1. Num set n minus 1 will start from here, and then from backward directions n minus 2 to k greater than 0, what we will do, we'll find the suffix, right? How will we find the suffix? Suffix k plus 1, and we'll take nums at k. Which one is max? That will get stored in the suffix max. It means in this way we will store backward directionally, we will store the suffix max, and so we have to iterate now over the j, so we can use the prefix max and suffix, and we'll calculate the max value, right? So max is nothing but result, right? And for that we'll start from j equal to 1 to n minus 1, because we have already calculated I and k. Now it's time for j to use over the prefix and suffix. So if you find the max difference, we'll get from what? Prefix max j minus 1 minus nums at j, right? So this is the best we will find from here, right? Nums at I minus nums at j. So to do that, you will do nums at let's suppose you are doing nums at I minus nums at j, right? So you have to assume prefix max is nothing but nums at I, and nums at j will remain same because we have not used till now. Then we will find the max. Max will come from the, if result have already some data here, let's suppose 0 or other value, then we'll we will find from the other value a and b, you can say which one is max, will get in the result. So max difference will multiply with the suffix max. Suffix max, you know, nums at I minus nums at j, and this is your suffix max you will get, right? Max difference you will get, and then nums at k you will multiply it, right? Nums at k is nothing but suffix max, and you will have your result, right? So better you pause this video, try to rerun again, right? But the main thing is that why we have created this one, right? So we have optimized the you can say complexity from O n q to O of n. Why? Because see, we have created array that will store O of n size, and if you see the for loop, it's going from O of n, so the prefix max computation will be O of n. Similarly, if the suffix max you will tell, it will also be O of n, and if you pass a single you can say j iteration, this is also O of n. So if you compute all these three, it will become O of 1 only, right? O of n only, right? Not the O of n q, right? That was happening in the last time. That was the previous solution was getting time limit exceed exceptions, and we are not.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel.